Okay, for the first example that we have here, I want to make sure that you know the steps for naming of the compound. So when you are naming a compound, what's the first rule of the IUPAC?
See what is the longest carbon chain.
You're looking for the longest carbon chain. And can you tell me how many carbon we have in the longest chain? And it has to be longest continuous chain of carbon.
7.
Okay, let's look at it.
6, so it's hexane, I think.
6, 7, anyone else? So if you say 6, you probably have used the straight line 1, 2, 3, 4, 5, and 6. And that may not be the correct one.
I see it, 7.
You see 7. Okay. 7, that means you did 1, 2, 3, 4, 5, 6, and 7.
I did it from left to right. Is that also correct?
Yes, we just look.
Okay.
First step is to find the longest carbon chain.
Okay.
So yes, it is correct and is better, but at the first we want to find the longest carbon chain. Is this the longest carbon chain we have?
No.
No. So you have to be careful with the longest carbon chain. So with the longest carbon chain here is going to be 1, right? 2, 3, 4, 5, 6, 7, and 8. So you look all possible ways and then find the longest continuous carbon chain. Step 2, you have to decide, do you have to go from right to left or left to right? And in this case, you went from left to right because you have more branches on the left side, right? Any carbon or group that did not take a number is considered as a branch. So we have 3, 4, and 5 branches. So if we have 5 branches here, we have to name each branch first, and then we place them in the alphabetic order. And if we have like terms, we are going to combine them. For 2 like term or like branch, we are going to use di. For 3 is going to be tri, 4 tetra, and 5 penta. So what are the the name of the branches and the location? And we are considering the green numbering system at this point. We have methyl group on carbon number 2, another methyl group on carbon number 2, and methyl group on carbon number 3. We have methyl group on carbon number 6. So we have 4 of them. So it's going to be 2, 2, 3, and we separate the numbers by comma. We separate the number from letter using a dash line. 2, 2, 3, and 6. Then it's going to be tetramethyl. Tetramethyl. So that takes care of 4 of the branches. We have another branch that is on carbon number 4, and that is isopropyl. So we have also 4 isopropyl. When I'm writing the name, which one should come in first, isopropyl or methyl? So you combine all the branches and you name all the branches, you give location. When you are writing the name, you should start with, you should go with the alphabetic order. So which one should come in first, isopropyl or the tetramethyl?
The isopropyl.
Isopropyl. The prefixes that are used in alphabetic order in consideration is only the iso, actually. But if you have di, tri, tetra, the T does not count, and only the first letter of the actual branch would count. So you're comparing I with M, and since I comes before M, is going to make it for isopropyl comes first before the methyl group. So to write the complete name for this compound is going to be 4-isopropyl. So 4-isopropyl. And we want to separate the letter from the number by dash line, 2, 2, and separate the numbers by comma, 2, 2, 3, 6, tetra, methyl, and what comes last? 8 carbon, so it's going to be octane. And that is the name for this compound. I just wanted to review one complex structure. So if we have like one complex structure, we're just going to cover few rules of IUPAC when you're naming alkane. So any questions about naming alkanes?
Why do we, sorry.
Do we have to put a dash between the L and the O?
A dash line would separate number from letter.
Right, but it's tetramethyl and then dash octane, right?
No.
Wow.
These are 2 letters. No, these are 2 letters, so you don't have to separate them. Tetramethyl
Okay.
octane. Yes, you only use the
Okay,
dash line when you are separating a letter from a number. Letter from a number, so you would use dash line.
Okay.
2 numbers by comma, but if you have 2 letters, don't know nothing.
Okay.
Okay, any questions about naming?
I missed why you said the T doesn't count for tetra.
Yes, okay, the prefixes normally does not count. So when you are counting, when you are looking for the alphabetic order, look for the name of the branch always, with exceptions to iso. Iso is the only exception. So if you had like a mono, di, tri, or tetra, any number that you had as a prefix, so just in general, prefixes do not count, with exception to iso. The only one that counts is iso. Okay, any other questions? If you remember any questions from the slides, up to slide number, I don't know, just the naming, just before physical property. If you have any questions, let me know. No questions? Okay. About the physical property. For physical property, we have effect of the intermolecular forces that is going to determine the physical property. Now, if we're talking about alkane, they all alkanes, they only have van der Waals forces or London dispersion forces, because alkanes are non-polar. So because they are non-polar, we're looking at the only intermolecular force, which is the London dispersion. When you have London dispersion, then there are 2 factors that it's going to be, 2 secondary factors that is going to affect the physical property. One is if you have compound 1 with 4 carbon, okay, 4 carbons, and then you have a compound 2 with 5 carbon. So you have 5 carbon here, and then you have your compound 3 with 5 carbon, but 1 is branch. So this is also 5 carbon, but one of the carbon is used as a branch. Which one has the highest boiling point?
Wouldn't it be the 5 carbons because it's a straight chain?
Which 5 carbon? We have 2 5 carbons. So
The one that's a
this kind of
straight
number
chain.
is 1, 2, and 3. Which one would have the highest?
Number 2.
2 would have the highest boiling point. Then between 1 and 3, which one?
1 and then 3.
Any other comments? Anyone else?
Would the branched one have the highest boiling point?
Why the branch one? Branch one compared to compound 2, or branch one compared to compound 1?
Branch 3 compared to the others?
Okay. There
3
are
compared to 1.
so learn it this way. There are 3 factors. One is the type of intermolecular force. The stronger intermolecular force, it gives the highest priority. So if you have a compound with 2 carbon only, but with hydrogen bonding, that would have the highest boiling point. When it comes to alkane, since they all have same intermolecular forces, then you don't have to worry about the primary factor, which is more important. But you don't have the difference here. There's no point of difference, so you don't have to worry about it. There are other 2 factors. One is the molecular mass or number of carbon per molecule. The second one is branching. Which one takes the priority? Number of carbon or branching?
Branching.
No.
Number of carbon.
Number of carbon. Number of carbon takes the priority. Because number of carbon takes the priority, compound 1 has 4 carbon, compound 3 has 5 carbon. So 3 is going to be higher than 4. Between 2 and 3, they both have same number of carbons. And since they both have same number of carbons, the compound with straight change or least branching is going to be higher in boiling point, because the surface area or surface contact area is greater. As a result, the intermolecular force of London dispersion is going to be more effective. So it is greater for straight chain compounds compared to the round or the more branch compounds. So we have there are aspects of of each family. As I said, the first day of class, we are looking for naming. So we should be able to have to name these compounds. So at this point, since you already watched the videos, I expect you to know about the prefix for name of the alkane, which is like met, et, prop, but, pent, hex. That's the prefix that shows how many carbon you have in your molecule. And then A and E for the suffix or the family name. That means you have alkane. So you're talking about alkane. So when you say met and ane, met represents how many carbon, and A and E represents that this compound belongs to alkane. Name of branches. You need to know the name of branches. So you have, if you have a methane, methane is 1 carbon with 4 hydrogen. Now, if methane loses 1 hydrogen, it's going to change from CH4 to CH3. So has lost 1 leg, it becomes ill. So you have methyl, okay? Methyl branching. So if you have carbon in a composition, in a structure that you have carbon with less than 4 bonds, is not a compound. It's most likely a branch that it has to be attached to something else. So you have methyl, ethyl, propyl. So name of the branches. There are few names that you have to memorize, like the isopropyl, sec-butyl, isobutyl, and then you have the other ones are very straightforward, methyl ethyl propyl. So if you have a complex branch, then you have to name that complex branch following the IUPAC rules as well. Let me look at the chat. I'm sure there are some questions in there. The screen is not centered. What should I do? Okay. Okay, sure. Okay, so we know about the naming. Next is physical property and some chemical reaction. We have limited number of chemical reactions for alkane. You learn some of these chemical reactions in the next chapter, but cracking, hydrocracking, when you break the bonds, when you break the number of carbons to smaller pieces, if you break the molecule that has, let's say, 8 carbon, okay? So if you have a compound that has 8 carbon and you break it by heating up, so if you break it, one, two, three, 4, 5, 6, 7, and 8, if I counted correctly. So if you break this down to 2 4-carbon structure, do we have enough hydrogen to make for 2 compound with the 4 carbon? Do we have enough hydrogen to make 2 butane? So if we have octane here, if this is octane, can we make 2 butanes?
Yes.
Okay, octane, what's the condensed formula for octane? 8 carbon, how many hydrogens do you have for octane?
16. This is your example. You using your example from lecture?
I don't know.
Yeah. Yeah. So it's.
So with 8, I don't know.
18.
I just it just happened to be 8 carbon.
Oh, okay. Yeah.
So how many hydrogens we have? 8. If we have 8 carbon.
18.
16 or 18?
18.
18. Thank you. Okay. So we have 18 hydrogen there. And for butane, how many hydrogens do we need? We know that is 4 carbon, but how many hydrogens? C4H?
10.
10. And for this one, we need, if it's a C4, what do we need?
Well, it'll be 8 to make it up to 18.
Okay, so it's only 8 hydrogen left, right? 8 hydrogen left. So that means we cannot have 2 butane from 1 octane. This reaction is called cracking or just breaking the bond. If you do break the bond without providing any hydrogen, you have to get like a butene here, which is the 1 alkene, 1 carbon-carbon double bond. So it's not going to be butane, it's going to be actually butene. Okay? It's going to be actually butene. So 1 alkene. If you add hydrogens here with the 2 hydrogens, then you could have butane. Okay, that's called hydrocracking. A specific structure for cycloalkane, that's another part, a major part of this is a major part of this very good, this chapter. stability of cyclohexane. When it comes to cycloalkane, they are not very stable, especially if you have a cyclopropane, cyclobutane. The most stable one is like cyclopentane and cyclohexane, and that's because of the angle strain. If you have here sp3 hybrid carbon, because there is no double bond, with the sp3 carbon is going to be 109 expected, but you are forcing that to 60. So if you are forcing 109 degree to 60 degree, that is causing angle strain. So it makes the molecule very unstable. Same thing here for the reducing from 109 to 90 degrees is going to be very unstable. But when it comes to cyclohexane and cyclopentane, they are more stable because it's expected to be 109 and is about like 108 for cyclopentane. And then cyclohexane, it changes composition or the structure or orientation in the space in a way that it forms like the most stable form of it is going to be chair composition or chair conformation, sorry, with the chair conformation. And what you need to know about chair conformation, I'm sure you already watched the video, you have everything else about the conformers and all that. I just want to emphasize on the stability of chair conformation of cyclohexane. For the cyclohexane, each carbon has two hydrogen or two positions. Okay, one is the red colors, all the red colors are which are parallel to each other and parallel to the axis of this molecule. They are known as axial, and the green colors are equatorial. That's one thing you need to know, like by heart. For each carbon, you have the two attachment or two bond, one axial, one equatorial, and then it alternates. If the axial for carbon 1 is up, axial for carbon 2 is down. Okay, axial for carbon 3 is going to be up, and axial for carbon 4 is going to be down, 5 up, and then 6 is going to be down. Same thing for equatorial is going to alternate. Equatorial down, equatorial up, equatorial down. So for every two carbons that is the consecutive carbons, you have carbon 1 and carbon 2. If the axial for carbon 1 is up, axial for carbon 2 is down. So if we have this structure, for cyclohexane, for cycloalkane, you could say cis or trans. That means the two branches are on the same side or on the opposite side. Can you tell me for this compound, if the branches are an axial or they are equatorial or one axial, one equatorial, what is the situation for this structure that I have it in the box? And how would you know that? If I call this carbon 1 and this carbon 2, is this group on carbon 1, is it axial position or is it in the equatorial position?
Equatorial.
Equatorial, and what about the second one?
Axial.
Axial. And why does it have to be on the axial? Is this cis or trans? This is cis compound or trans compound? Or trans isomer, cis isomer or trans isomer? You know the difference between wedges and dashes, right? So if you have this dashes line, that means that it's going away from the surface. If you have the solid triangle, that is coming out. Since both of them are solid, that means both of them are coming out or coming toward you. Since both of them are on the same side, that makes this molecule cis molecule. So we have cis here. This is a cis molecule. If it's cis, that means both of them are up. Both of them are on the same side. Okay, both of them are up. So the first one, for the most stable structure, you want the first one to take it as the equatorial. If the first one is equatorial, the second one has to be on the same side. If the first equatorial is up, the second equatorial is down, but since this is up, cannot be equatorial, so it's going to be axial. So one is equatorial, one is axial. One equatorial, one axial. Does it make sense?
Yes.
Can you
I'm a little
just imagine,
confused.
you have to go stepwise, just look for the steps. What I did first, I looked at the structure of the compound and I determined if this is cis or that is trans, okay? So that's the first step. This compound is cis compound. What does it mean? It means both branches are on the same side. That's one thing you need to know. And you also need to know that if you have axial up for carbon 1, axial is going to be down for carbon 2. If the equatorial is down for carbon 1, equatorial is going to be up for carbon 2. These two positions are 1-2 position. Okay, so this is a cis 1-2 cyclohexane. So if it's a cis 1-2 cyclohexane, we just take this for now out. Okay, cis 1-2. So that means both of them are on the same side. If one is on the axial, the other one must be on equatorial. Because when you look at the structure, the plane structure of the cyclohexane without any branch, just looking at the positions, if the axial for carbon 1 is up, axial for carbon 2 is going to be down. But since it's trans and both of them has to be up, the only combination that both of them is up is one axial, one equatorial. Now your questions. Tell me about your questions.
No, you cleared it up. Thank you.
Okay, perfect. Perfect.
Also, could you just go over, it's really quick, sorry. You just went over it talking about the cyclohexane and cyclopentane. Which one is the most stable?
It depends on both of them. These two are the most stable compared to other cyclic systems. So if you have a cycloheptane, is not stable. If you have a cyclobutane, is not stable. Cyclopropane is not stable at all. And we don't have cycloethane because you have to have at least 3. The reason they are not stable because is the difference between the bond angle that you have in the molecule compared to what is expected from the hybridization. If you say hexane or pentane, that means it's saturated. And if it is saturated, hybridization for the carbons are sp3 hybrid. And if it's sp3 hybrid, the bond angle is supposed to be 109 or expected to be 109. Then the deviation from 109, the further away is from 109, regardless if it's being higher or is being lower, is going to make the molecule unstable. So the closest one is going to be cyclopentane and cyclohexane in the chair conformation. So both of them are stable. Let's look at this structure here. Can you tell me what are the positions of the branches for the most stable? Is this because we have 2, and just imagine this is cyclohexane. 2, is this diaxial or diequatorial? And how do we know? For the most stable structure. Or what are the two choices for this structure? The positions of the methyl group, would it be on the axial or equatorial position?
Equatorial.
Both equatorial?
You said that one has to go up and the other one gotta go down, and then I see both.
Not now. Look here on the structure, yes, the cyclohexane, but this compound, this example, what we have is both of them are coming toward you. So both of them are up. But now the question is, are they equatorial or axial for most stable one? Knowing that if you have only one branch, it has to be on equatorial for most stable. If it's an axial, you have these two, like you have the position 3 and 5 very close to it. So those are the, it causes like hindrance. They are too close because they are parallel to each other. So if you have one branch only, it must be an equatorial. If you have two branch, the bulky one has to be on equatorial. If you have 3 branch, the bulkiest one has to be on equatorial. And then you look at the position. So it's easier. You take the first one, because these two are the same, you take the first one and say this is equatorial. The second one, look at the position. And if the equatorial for carbon 1 is down, okay, if the equatorial for carbon 1 is down, for carbon 2 is up, carbon 3 is also down. If the equatorial for carbon 1 is up, for carbon 3 is going to be also up. So you look at this is equatorial. If this is equatorial, then this would be equatorial position, and this would be equatorial. So both of them is going to be equatorial because they are on the same side. For the 1,3 position, both of them are on the same side, so both of them are equatorial for the most stable structure. Did it make sense?
Yes.
How many equatorial branches you have on this molecule? This is going down.
Two.
2 equatorial. Okay, which one must be on equatorial? We have a methyl here, methyl and isopropyl. Which one must be on equatorial?
Isopropyl.
Isopropyl must be on equatorial. So this one is equatorial. That's for sure, because we want stability. The bulkiest must be on equatorial. Now, if this is equatorial, down next to it is up. So if the up position, is it equatorial or axial?
So
Axial.
Let me ask my question one more time. If in this position we have equatorial down and the adjacent carbon, what is up? If the equatorial is down in one carbon, which position is up on the next carbon? Equatorial is down in one carbon, on the adjacent carbon, which position up? Equatorial or axial?
You said it's equatorial, right?
Yes. Isopropyl must be equatorial. Okay, this must be equatorial because it's bulky, but it's going down. If the equatorial is down on this carbon, an adjacent carbon, equatorial is going to be up. So this is up, and it has to be equatorial also. Going this way, equatorial down, equatorial up, equatorial down. But since this is not down, it must be axial. So you can put, for this position, you say equatorial down. Okay. For this position, equatorial down and axial up. Equatorial down, axial up. For this position, what's happening for this position? On the adjacent carbon. Equatorial down here. So for this position, equatorial is going to be up and axial has to be down. What's happening in this position? What happens to equatorial? Equatorial is going to be, it alternates.
Down.
Equatorial has to be down and axial is going to be up.
Up.
For this position.
You said it has to be axial. Which one?
Okay.
Right there?
Let
Oh,
me go
okay,
here
that'd be up.
first. Go here first. So in this position, equatorial has to be up, right?
Yes.
And axial is going to be down. For this position,
You said because it's up, but it rotates. So you said it was axial.
the axial is going to be up, equatorial is going to be down. So
Down.
you just have to look at it alternates. It's going to alternate. Axial is going to be up. So in your mind, like you may not have time to write all of these, okay? You may not have to write, but with the practice, if you do like 10 or 20 practices of this different structures to determine is it going to be an axial position or equatorial position, then it becomes very natural. So you would say, okay, the bulkiest group has to be an equatorial. So we already know this is equatorial down. And from this structure that we have in the box here, we know if equatorial in one carbon is down on adjacent carbon, equatorial is going to be up. So if equatorial here is down and both positions on the both sides, equatorial is going to be up. Since this branch is up, then it has to be equatorial. So we have one equatorial here, second equatorial, and this is going to be axial because it's up. In this position, equatorial would be down, axial would be up because it's a 1-3 position. So what else you could see from the from this structure is that if you have 1, 2, carbon 3, carbon 4, and carbon 5, you see what is the 1-3 diaxial? Trans or cis? 1-3 diaxial. What it means that you have two groups on the axial position. Would it be cis or trans? 1-3 diaxial.
Cis.
Is going to be cis. 1-3 diaxial is going to be cis. What about 1-2 diaxial? When you say 1-2 diaxial, that means that you have carbon 1, if axial is up, carbon 2, axial is down. So when you say 1-2 diaxial, that is going to be trans. What about 1,4 diaxial?
Cis.
1,4 diaxial. So if 1 is up, okay, 2 down, 3 up, 4 down. So 1,4 diaxial is actually going to be trans. Okay, I'm just gonna, I don't want to put too much, too much information. Maybe you learned a different way, but I want to ask you a different, like put different question, different format of the question. Let's say if I have this structure for cyclohexane, that I know this is going to be a CH3 here, just a line, and CH3 there, and I have a CH3 here. And if I say that this is trans, are those going to be on the axial or equatorial position? We don't have the wedges and dashes, so we don't know if it's coming out or going in. We have the option, but we know that this is trans. Are the methyl groups in axial, equatorial, or one in each? What would you do? What would be the first step? What would be the first assumption? Can you tell me steps? What would you do first? Would you take the first one to be on the axial or equatorial position? Because they are the same size, it's safe to take the first one as equatorial, because you want at least one of them to be on the equatorial position. Okay, so if this is equatorial up, what happens here? Equatorial would be down, and in this position, equatorial is going to be up. This methyl group is on equatorial is up, but this compound is trans. So what should be this methyl, the second methyl group? What position, equatorial or axial? In order to meet this definition of trans.
Axial.
It has to be axial. Very good. So this is going to be in axial. Why does it have to be axial? Because someone already told us that this is a trans. We take one of them in the equatorial position and then look for the other position, like you just move down or move left or right until you get to the other branch and see what position is possible for that. Are you restricted? If you were not restricted, you would put the other one also in the equatorial position, but you are restricted to what? To this definition of trans. If this is an equatorial and you assume that this is up, then in this position, equatorial is also up. If you place this methyl group in equatorial, you're going to change your molecule to cis molecule. To avoid that, you just put this in the axial position to make it trans. Okay, obviously the examples that I had on the whiteboard today, they were the most challenging one of the chapter. You have more than like 45 slides in that chapter, but I just wanted to make sure that I cover the most challenging of all. And, you get plenty of different types of questions from this chapter, but you will also get question of, this type on the quiz or the exam. So please review. You have a lot of examples also in the assignment folder. What I did, or I was able to do for today, is that I create the groups. With the groups I update the Zoom. So now you can add your name to a group. At this point, instead of going to quiz, I already hide the quiz 3 from your view. Nobody is able to see the quiz 3, right?
No.
Okay,
No.
good. So instead of taking the quiz first, I want you this time to go do a group work. You can work on the assignment, and also I want to make sure that you can form the groups that you had the first day and you were asking for it. Now you should be able to join the group that you were in the first. If you don't remember your group number from the first one, breakout room, I put pictures in a folder. In the home page is called co-op group arrangement. So please look at that picture, the picture, find your name, and then tell me, I can help you while we are in the main room. But if when you go to the breakout room, then I have to come actually to your room in order to come. I allow you to come out of the breakout room, come to the main room to ask questions, or just raise your hand while you're there. I will come. If you want me to switch you around, you tell me. But just remember, from now on, every time we form a group, I'm going to allow this participant to choose the room, and then you go to the same group. If there is any modification, is going to be done today. And then after today, we're going to have a fixed members per group. And the co-op assignment, because it's a group assignment, one submission with name of all group members is going to be fine. And it's up to the group members to not include someone who did not participate in the, helping to. So I just leave that up to you. But OR assignment is individual submission, and each person needs to submit one. Because of these examples that I had on the board, I'm sure you are going to be able to explain to each other a little bit more and go over some of the examples. I'm going to give you only 15 minutes. Would that be enough for discussions about the OR assignment, to go over some of the examples to make sure you understand? You can answer some of those questions or help each other. And we start the quiz at 9:15 today. Is that good?
Yeah, so we're only going over the chapter 3 packet, not the group
Chapter
packet.
3, just because this axial, equatorial, and
Right.
cis and trans, especially, and then naming. If you have any questions that I didn't address, or you were not going to ask me right now, I want you to go over that. And since now we have like fixed members of the group from now on, so you can also assign the number of questions that you will be working on from the chapter 3, chapter 2, and chapter 1, to make sure that you have everything ready before next meeting, because you have few days now until our next meeting, and that's the chance for you to also make sure that your OR assignments are done. You work individually during this time, but to have someone responsible to answer your questions about that problem is going to help you a lot. I mean, you can help each other. If you know, teach others. If you don't know, ask from others. And we're just going to use about 15 minutes for the group work today. I'm going to give extra like 2 minutes, because is the first time that you are joining the group, you may have to go back and forth, try to find your name in the group that you were before. I created 7 rooms like we had before with the 29 people. One person, I guess, has a internet problem, is going back and forth. I hope that, student comes in time, but at least 4 people in a group. If you lost 2 people from your group and we have new people, we just have to readjust it. I'm going to open the rooms right now. Join the room number that you were in the first day. Pictures are found in the file. Can anyone locate the pictures?
Professor,
Yeah.
we can't find the photos.
You cannot?
No.
Can you go to go to the course content, or go to the content and then look for, let me see, exact name. The exact name that I have for that file is called Co-op Group Formation Form.
Yeah, when you click on it, it's just blank. It's like a form, but we have to fill it out. There's nothing filled out there.
Yeah, it's
I
a
think-
Word document.
Believe me, I did upload the pictures. You see the picture.
I mean, I can, if you give me access to share my screen, I can
I
show
know,
you.
I see that. I see that here, but I did upload. I did upload. Which one did I upload? I can upload again if it's not there. Maybe it's course builder. Well, I'm one step closer. I was able to update the. Okay. Oh, group division. Can you see that? Okay, it's not published. Okay. Publish it right now. Okay, can you look for the folder? It's called Co-op Group Division.
Let me check.
It says 2018, but I'm going to change that to 2021.
I see it now.
Yeah, I see.
Okay, perfect, perfect. It wasn't published, I'm sorry, because I just did that for you. Okay, so you have the pictures. Okay, I'm going to open the groups at this point. Join the group, and I'm going to, again, adjust the time for the quiz. The quiz is going to start at 9:17, or I'm gonna see when the groups are formed. I give you just 15 minutes time for it, okay? The rooms are open. Can you please join?
Yeah.
Do you know how to?
I know how to.
Perfect. Isabella joined room 2. Perfect. And if you, if any of you have trouble locating the pictures, you tell me, and I will